This topic is angular momentum. Angular momentum is a quantity measuring the radius of the curve that an object is traveling in times its linear momentum. Like linear momentum, angular momentum is conserved. If we take a look back at the old linear momentum equation that we learned, it's P equals m times v. We're going to be able to relate and derive the equation for angular momentum. So the symbol for angular velocity that we used was omega, and the actual equation that we used in the previous topic was the change in the angle divided by the change in the time. Another way to write this expression is the tangential velocity divided by the actual radius. So now if we actually solve for v, here we have v is going to equal the angular velocity times the radius of the lever arm of the lever. So if we have a circle, this is a very poor excuse for a circle. If we had some type of a rod traveling about this axis, rotating, it would have angular momentum. So to actually derive the angular momentum formula, we're going to take this formula here, and we're going to use a new symbol for angular momentum, and that's going to be L, and we're going to take, we're going to have mass, and instead of having velocity here, we're going to substitute this in for velocity, and that's going to be WR. So that's, omega R. So that'd be the formula for angular momentum. The concept of angular momentum, the best example that we can provide is in terms of figure skating. So if we see figure skaters, they often like rotate on the ice. They spin on the ice. You see them kind of extending their arms and then bringing their arms back in and out, in and out. How this works is, since angular momentum is conserved, this is going to be a constant. So angular momentum is going to be a constant. Because it's a constant, we have a relationship between the angular velocity and the radius. So basically, if they're going to be indirectly proportional. So, for example, when you see the figure skaters increasing the length of their arm and then decreasing the length of their arm, they're basically changing their radius. As they change their radius, because angular momentum is constant, is conserved, that's going to change the angular velocity. So, for example, if I increased the radius, that would cause a decrease in the angular velocity. And the opposite would hold true. If I decreased the radius, that would cause an increase in the angular velocity. The equations that the only equation that we're really going to need to know here is the equation I just kind of went over. It's L, angular momentum, equals R times M times v, the perpendicular component of v. Angular momentum, the only new variable here is angular momentum, and the unit is going to be Newton meter second.